In this last video for section 2.1, what I'm going to go over are applications. I'm not going to solve every application problem. Mostly we'll focus on setting them up, although I will solve this first one to illustrate a couple of points. So this is really good practice for later on. I keep mentioning it, but in the end, we're going to be dealing with many equations, many unknowns, and practicing with these smaller ones will help us get better skills for when we approach those problems. And so in this one, we're talking about supply and demand, something you should read about in your text. There's a graphic in the notes right before this that is also helpful. So let's focus on what it's asking for and what it means. So it tells us a gift catalog company estimates the demand equation for its portable video player to be the following. I'm going to go ahead and write that down here. I always do this when I'm working these types of problems. Is any information that I think will be helpful, I write out so I don't have to keep going back to the giant wall of text above me. Okay, so X is demand quantity in thousands. That will be important later on. And P is the price. Okay, and then the supply equation is estimated to be P equals 12.5x plus 325. Notice what I've done is I've set this up so that it looks like a system of equations, right? And that's exactly what it is. In this case, X is the supply quantity in thousands. Again, just like before it was demand quantity. In both cases, X is essentially the quantity in thousands, and then P is the price. We want to find the equilibrium quantity and price. What that means is we want to find where demand and supply are balanced. And that would be the intersection point of these two lines where P is taking the place of Y essentially. Now, I wanted to talk about this one because of how we solve it. Notice how it's written a little bit differently than before. It says P equals this and P equals this. Well, by substitution, couldn't I replace the P in the second equation with this one? In other words, if I did that, wouldn't I get minus 10x plus 640 equals, because I just put that there, 12.5x plus 325? I mean, doesn't it work like that? And now I have an equation in terms of x that I can solve for, and then I can plug it back in and all that. So for this one, I do want to go through that. If I was to bring the 12.5 over, I would get minus 22.5x. And then bring the 640 over, I'm going to get 325 minus 640, which I'm checking on the calculator is negative 315. So x is going to be negative 315 divided by negative 22.5. And so I get 14. Okay, now even though it's in thousands, don't worry about that just yet. We want to figure out what P is, so I'm going to plug that into the very first equation. So P is negative 10x, so it's negative 140 plus 640. In other words, it is 500. Okay, so the equilibrium quantity is not 14, because remember this is in thousands. This would be 14,000 video players. And the equilibrium price is going to be $500. This is where I think you see the age of your textbook, right? Portable video players aren't that popular. And I don't imagine that anybody would pay $500 for them. But ignoring that, this is what the information we're looking for. So this can be applied to all kinds of situations. And again, you should really read over the idea of supply and demand in your textbook, because we'll be dealing with it a little bit more later on. Now let's look at some where we have to set up the equations. So here's a very simple one. We're just told some investment information. So we have $5,000 invested in securities. Part was invested at 9%, part at 8%. And the total income from that, so the total result after investing, was $415. And so we want to know how much was invested at each rate. Whenever you're approaching these problems, you want to make sure to set up your variables first, and set up your variables so that it answers the question. The question is how much was invested at each rate. There's two rates, so we need two variables. I'm going to call them x and y. So x could be the amount invested at 9%, and then y could be the amount invested at 8%. Without naming your variables, you have no idea what you're doing. There's no way to write equations. Now, you don't have to call them x and y. You can call them whatever you want, as long as you define them clearly at the beginning. Now, to find two variables, we're going to need two equations. The first thing we're told is that $5,000 was invested. So the total was $5,000. If the total was $5,000, that tells me that X plus Y must be $5,000. And then we're told that when you combine the total annual income, so when you combine the incomes, you get $415. Well, what's the income? Well, it'd be 9% of X plus 8% of Y, and you should get $415. Now, I'm just going to set this up, but you should certainly be able to solve this system, right? This is something you should be able to do using any of our methods, but this would be the setup. And if I ask you to set things up, I'm going to ask you for the variables, and I'm going to also ask you for the equations. And later on, I'm going to ask you for any constraints. For instance, constraints would be something like we know X and Y can't be negative. Things like that will be important with some other applied problems. And it's important here too when you actually solve it. Okay, so there's one example. Let's take a look at another one. And so in this one, we have a lot more information, it feels like, but let's take a look and I'll show you another key to doing this stuff. So we're told a fruit grower, I guess you could call that a farmer, uses 2 types of fertilizer in an orange grove. So we have brand A, brand B. Notice what we're told. I'm kind of scanning. We're told the amount of nitrogen and phosphoric acid in each type. And then finally, we're told that the grove needs a certain amount of nitrogen, a certain amount of phosphoric acid. How many bags of each brand should be used to satisfy that? Remember, I want to set up variables to answer the question, how many bags of each brand should be used? So what I could do is set up my variables. There's 2 types. There's A and B. So A could be the number of bags of A to use, and B could be the number of bags of B to use. Now, the next question is, how do I set up the equations? It's not as straightforward as the last one. The second trick to this is to combine like information with like information. In other words, we have lots of information about nitrogen, we have lots of information about phosphoric acid. Why don't we combine those? In other words, we know we need 720 pounds of nitrogen. We're going to have to get some nitrogen from A and some from B. How much nitrogen do we get from A? We get 8 pounds for each bag. So there's our nitrogen from A. And when you combine it with the nitrogen from B, which is 7 pounds per bag, you need to end up with 720 pounds. Similarly, with phosphoric acid, you get 4 pounds from A, you get 6 pounds from B, and you need to end up with 500. Notice how I combined information here. And then later on, we'd consider stuff like, okay, can these be negative? Can these be fractions? Can we buy a fraction of a bag? Maybe, maybe not. But in the end, the key right now is the setup. And so this would be our system of equations that we could use to find A and B. And again, you should be able to solve this relatively easily. So again, the 2 keys, make sure your variables answer your question and combine like information with like information.